This is spiral number 1.2-4. We're given a motion diagram for an object. This object starts here, and if I follow the direction of the arrows, it reaches a maximum height right here, and then it falls straight back down. They don't want to draw those two things directly on top of each other, so they kind of draw the downward part of the trajectory over to the right. But this is the same point in space and the same moment in time. It's just we're drawing them next to each other so they don't overlap. And the question wants me to determine for these 3 points here that are circled, this one, and this one, we're going to determine what is the position, the velocity, and the acceleration at that moment, at each of those moments. And we're going to determine whether the position, velocity, and acceleration are positive, negative, or zero. One thing that's a little not obvious with these problems is that this thing off here to the left, that is the coordinate system. So that is the thing that determines where our origin is and what is the positive direction. So by putting this little axis here, what that is telling us is that this is our y equals 0. That's going to be our origin point right there. This is the y equals 0, and then they also tell us pointing straight up is the positive y direction. So we're going to use that to answer these questions about these points. Let's look at this point right here. First, we can look at the position. It's above that y equals 0 part of my axis, so that's going to be a positive value for position. The position is some positive y number. For the velocity, when we talk about the sign of the velocity, is the velocity positive, negative, or 0, we're looking at what direction is it moving in at that moment in time. Well, it's moving in this upwards direction. We can tell that by these velocity arrows here. It's moving upwards, and the coordinate system defines upwards as positive, so our velocity at that moment right there is going to be positive. Now, to determine our acceleration, that's a little bit trickier. To determine the acceleration, we have to look at how the velocity is changing. So the magnitude, or the number part of the velocity, is represented by the length of these arrows. And this arrow here is bigger than this arrow here, which means the object is slowing down. The velocity as it moves from this point to this point is bigger than the velocity as it moves from this point to this point. So the object is slowing down. And we can kind of recall this rule that's really, really helpful. When an object is speeding up, the velocity and the acceleration have the same sign. When an object is slowing down, the velocity and the acceleration have opposite signs. So let's come back here. We have determined that it's slowing down, okay? And we've also determined that the velocity is positive, which means at this point the acceleration has to be negative because it has to have an opposite sign because it's slowing down. Okay, let's look at this point here. These are we're at the same point right here. The position is above that y equals 0, so it's going to be a positive y value. It's not obvious, but I think they're indicating this is the moment in time where the object changes direction. Because the moment before that, the velocity was moving upwards, and the moment after this, the velocity is downwards. So the velocity at the moment that an object changes directions is 0. That's something we learned in our lab this week. And then finally, let's look at our acceleration. It's a little tricky because before that we were going up, but if you think before this we were going upwards, and right after that our velocity is 0, we're definitely slowing down still. Okay, compared to the moment before. From the moment before, we're definitely slowing down in that upward, that we were moving upwards and we're slowing down. That tells me that these two things have to be opposite. And if I'm looking at this previous moment when my velocity was positive, that tells me here my acceleration should be negative. Another way to think about it is if we look at the next moment, my velocity is downwards, and at this moment my velocity is 0. So if I'm going from a velocity of 0 to a downwards velocity, we're like speeding up in that downward direction. So if I compare to this downward direction, my acceleration should be in the same direction as that downward direction because I'm speeding up in that downward direction. Either way, both of those methods of reasoning tell me that my acceleration is negative. If we look at this point here, the position is going to be positive because we're above that horizontal axis, that y equals 0. My velocity is determined just by the direction the object is moving. Here the object is moving downwards, and our axis says up is positive, so down is negative, so my velocity is negative. And now for our acceleration, again, we're going to look at, are we speeding up or slowing down at this moment? Well, if I look at the previous moment, that's how big my velocity is. And at the next moment, my velocity is bigger. in that negative direction. That means I'm going faster. I'm speeding up as I move downwards. And when an object is speeding up, the velocity and the acceleration are the same sign. My velocity was negative, so my acceleration here is also negative. Let's look at part B. For part B, again, we want to look at this coordinate system and recognize that this position right here is our x equals 0. Let's look at this point on our motion diagram. Here, I'm to the left of my x equals 0, and they said the right, going to the right is the positive direction. So over here, my position would be negative. For my velocity, I'm just looking at the direction the object is moving. It's moving to the right. And this coordinate system says moving to the right is a positive value, so my velocity is positive. And then here, again, to determine the acceleration, we need to figure out, are we slowing up or speeding down? Sorry, speeding up or slowing down. That's what we need to figure out. So the way that we're going to figure out whether we're speeding up or slowing down is to look at the length of these velocity arrows. Here, this length is bigger than this one. That means at this moment in time, I'm going faster than I am at the next moment in time. That means that I'm slowing down. So once we determine that we're slowing down, we know that V and A have to have opposite signs, so my acceleration is going to be negative. Let's look at this point here. This motion diagram also represents something that moves forward, slows down, comes to rest for a moment, and then it moves back in the other direction. We don't want to draw those two paths on top of each other, so we just draw the second part a little bit lower. But this is the same moment in time. The position here is definitely going to be positive because I'm to the right of my x equals 0. My velocity at this moment, this is the moment that I change directions, because right before this moment I was moving to the right, and right after this moment I'm moving to the left. So my velocity there is 0. That's the velocity you have at the moment you change directions. And now for my acceleration, we can either look at the moment previous to this, where my velocity is positive, and now at this moment my velocity is 0, which represents slowing down. So I would want to have an opposite sign to this velocity, which would be negative. Or I can look at the velocity for the moment after this, which is to the left. And at this moment, my velocity is 0. And if then I'm moving to the left, I'm speeding up in that left direction, which would also mean a negative acceleration. Finally, let's look at this point. I'm to the left of my x equals 0, so my position is going to be negative. My velocity is pointing to the left, and my coordinate system defines to the right as positive, so that means to the left is negative for my velocity. And then for my acceleration, I want to use this rule, and I want to figure out at this moment in time, are we speeding up or slowing down? This velocity line is shorter, so this represents moving slower than this one. This one is bigger, so it's moving faster. That means that as we move through here, we're speeding up. When we speed up, our velocity and our acceleration are the same sign. My velocity we said was negative, so my acceleration is also negative.